Hello and welcome to this session of Introduction to Autonomous Systems. As you recall, since last couple of sessions we have been talking about the discipline of artificial intelligence and some of its basic features and characteristics. We now come to a point where we need to understand its overall canvas in terms of what are all the disciplines that ultimately will be required by us in order to practice the artificial intelligence systems as we have been talking about. So, let us begin today's session. In this regard, what I would like to mention is the contributions that various other disciplines have made, are making and will be required in order to set up a solution that is from an artificial intelligence perspective. Notable among these are philosophy, mathematics, economics, neuroscience, psychology, computer engineering, control theory, cybernetics and linguistics. Of course, there could be a few more which may also be contributing to the development related to artificial intelligence, but these are the prominent ones which need to be kept in mind while considering the design and synthesis of such systems. Let us now understand briefly each of these disciplines as to what their role is and what they bring to AI systems. So, let us first start with the philosophy. In fact, there is a saying that philosophy is the genesis of all disciplines, and obviously it includes AI. And the kind of things that it attempts to do are to try to find answers to the following questions. Can formal rules be framed to draw valid conclusions? An extremely important question for which we need to find answers. Then, how does the mind arise from physical brain? That is something which we, at least to the extent possible, we need to understand. Another important philosophical question, where does the knowledge come from? What is the source of knowledge? And how does knowledge lead to action? You will find that all these are essentially philosophical questions which have to be answered in the context of creating the various aspects of a solution of AI. For example, in the context of a system that we are talking about, we need to arrive at conclusions. So, are there rules or can there be rules which will lead us to valid conclusions, and so on. So, now let us see from where all these have come. So, ever since Aristotle gave his syllogisms, the other philosophers have come up with reasoning with mechanical artifact. So, this is what has been the primary focus of the philosophy in the context of AI, that can you reason with the mechanical artifact, or can you make the mechanical artifact capable of reasoning, which is essentially a human intelligence attribute. And this also led to computers that were thought to have ability to think, which means could you create computers which could think on their own. So, as an AI enabler, what does it do? Of course, the concept of mind as a computer has gained widespread acceptance by most of us, saying that ultimately mind is a calculating machine. But it still does not fully explain many actions that cannot be computed. There are quite a few things that are computed by mind, which is fine, but there are also many things which cannot be computed. So, this answer was partly given by Descartes, who propounded the philosophy of duality of mind. What he said is that there is one part of mind which is the calculating machine, does the computation, and there is other part which is actually outside the nature, which means addressing the issues of intangible, which we had discussed earlier if you recall. Philosophy also brought in the idea of knowledge through empiricism, empirical formulae, experimental data, curve fitting, inductive logic or induction, and experience, along with ways to apply it for an action to achieve the goal which the AI needed. So, this was the another contribution, or philosophy enabled the ideas of knowledge. Then comes the mathematics. Now, if we look at the very kernel of the contribution of mathematics to AI, we need to recognize the fact that philosophy of logic is credited to George Boole, or the formal idea of logic, and all of us are familiar with this term called propositional logic or Boolean algebra or Boolean logic, 0 and 1, true and false. We know all that. So, we know that this is one contribution which has come from the philosophy of logic and got converted into the form of a Boolean logic. So, mathematics is trying to find answers to the following questions. Now, you see, the first question is related to what the philosophy was asking. The philosophy was asking the question, can the formal rules be framed? Now, if the answer to that question is yes, then the next step is taken over by mathematics, which says that what are these rules then? Number one. Then it also asks the question, what can be computed? Because there is a calculating machine, the part of the mind. So, it wants to know what are the things that can be computed, and lastly, how do we reason with uncertain knowledge? Because philosophy gave the idea of reasoning. So, we now say, how do we reason with uncertain knowledge? So, these are the questions which mathematics tries to ask and find answers. And as a response to many of these questions, algorithms, which are important component of mathematical procedures, have an important place in our ability to compute quantities that can be computed. So, that is how the genesis of algorithm has come, that whatever can be computed, then you create algorithms which actually will compute them. So, mathematics as an enabler, what does it do? The first thing it has to do is realize that not all problems are computable. So, this is the first thing that has happened, because it has divided the whole domain of problems into two parts, the part which is computable and part which is not computable. But within that, the problems which are computable, they are also not tractable. What we essentially mean is that the problem size versus computational effort involved. So, this is one aspect which also AI as an enabler brings into the development of an AI system. And third important contribution of mathematics to AI is the theory of probability, because the last question, if you recall, was essentially to ask the question, can we reason with uncertain knowledge? So, mathematics has brought in various tools and procedures to capture some quantitative measure of uncertainty through the theory of probability, and then probably use it in the reasoning process. It is interesting to note that this whole theory of probability came out of describing the possible outcomes of gambling events way back in time. And in this context, we also need to note that the Bayesian rule for updating probability is the basis for uncertain reasoning in AI. We will look at this when we start our discussion on the Bayesian processes, but it is important to keep this fact in mind that the way you update probabilities is going to be the fundamental basis which will help us to reason with uncertain knowledge. That brings us to the next contributor to AI, that is economics. We will see how this makes a difference to our ability to create good artificial intelligence systems. The science of economics began around 1770 with a publication called An Enquiry into the Nature and Causes of Wealth of the Nations by a Scottish philosopher, Adam Smith. And the whole idea of this was to answer the following questions. How should we make decisions to maximize payoff? How should we do this when others may not go along? How should we do this when the payoff may be far into the future? As you realize, these are extremely important and critical questions which have to be answered. Just for example, if you look at the first two, they are already targeting your planning process of one of the attributes of artificial intelligence or autonomy. And the other part is that if the payoff is into the future, then what are the strategies that we should adopt? For example, when we create large projects which are going to take 10 to 15 years for completion, and that is when you will reap the benefits, like construction of metros, large dams and similar infrastructure components. Now, the actual benefit will come, let us say 10 or 15 years later, but you have to take a decision right now. How do you do that? That is a question that we need to answer. See, the basic idea of economics is that economies are the agents who are maximizing their own economic well-being. This is the fundamental idea, that everybody or all the economies, including the individual, ultimately is trying to maximize its own economic well-being. Of course, most of us think that economics is about money, which may be partly true at some level, but the economists themselves believe that it is not so. What they say is that it is the study of how people make choices that lead to preferred outcomes, or in other words, a utility theory. So, what they say is that economics is not really about the money. Money is incidental in this whole process, because money is one of the important element of preferred outcomes, that you would like to have more money by making some choices, but ultimately it is a study of how people make those choices which will increase their financial standing. So, this is the whole idea of a utility theory. In this context, the decision theory that combines probability with utility theory provides a formal framework for decisions made under uncertainty. So, now see we are coming to closer and closer to a possibility or a viewpoint how we can make decisions under uncertainty using a formal framework. So, you know that you are going to require mathematics, that is probability theory, you are going to require Bayesian update of probabilities, and you are going to require a formal framework given by the economics to carry out all these activities. Of course, the decision theory holds good for large economies. It has been found that for smaller economies, a game theory model works better. The game theory essentially talks about, let us say, two-player negotiation, bidding, and some amount of give and take, those kind of things which essentially have to be taken into account while deciding what should be done in a given scenario. Of course, this is something which is central to this whole idea of AI, particularly the last attribute of autonomy, that is self adaptation, and neuroscience is at the back of it. The neuroscience basically understands the nervous system and it tries to answer the following question: how do brains process information? Now, this is something which has remained mystery for a very long time, and it continues to be so, because despite all the research and investments which have happened in this area, there is still not too much that is known about how the brains function. But with all this uncertainty about how the brain functions, there is still a realization that the brain enables the thought. So, this is what people have realized and recognized, that brain will enable the thought. So, which means in order for us to understand the thought process and create thinking machines, we have to understand at least that part of brain as applicable to a given specific AI system. However, efforts to unravel the mystery have been ongoing, with identifying nerve cells or neurons as they are commonly called as the basic unit of brain, amenable to description as well as mathematical treatment. So, this is now the current state of research which people are looking at, that the neuron not only is amenable to a description, a reasonably good description as a model, and also it can be mathematically analyzed. Just want to show you a picture of how a neuron actually looks like. You must have seen this picture in many other contexts. So, it is essentially there is a nucleus, which is then the cell body or the main part, and then you have dendrites which end into synapses, and from synapses you start connecting it to another cell. So, these are the kind of tentacles kind of objects which that connect to another cell and communicate information back and forth. Of course, notwithstanding the fact that we still do not understand how cognitive processes work, there is some connection between brain activity and ongoing cognitive processes that people have tried to understand using the brain mapping, which are now being done as very basis of research in the understanding the brain, that is EEG or electroencephalogram, and MRI scans, where it is a active brain which is not under any sedation, and you as the person is making some thoughts or some activities, how the various electrical activity which is going on inside the brain can be captured and mapped. From an AI perspective, what neuroscientists have now finally come to the conclusion that a collection of simple cells can lead to thought, action and consciousness, which means there is a collection of simple cells. Number is at the moment not important, but the cells are simple, they are just simple input output devices. That collection, the combination can lead to thought, action and consciousness, and this normally they explain as saying that brains cause minds, that ultimately the mind, which is what the thinking machine is a result of the activities which is happen inside the brain. Of course, they also say that if you do not accept this, then the only other conclusion that people can draw is mysticism, that minds operate in some mystical realm that is way beyond physical science. Otherwise, you accept this idea that it is finally the brain which is causing whatever the mind or whatever thought which is coming in the mind. So, to conclude this part, we see that while economists bring in the ideas connected to optimization, neuroscience helps us to build better neuron models. With that, we come to the current session. In the next segment, we will take the remaining contributors to AI and understand their implication in the overall design and development of AI systems. So, thank you and see you in the next session.